Here is section 1.1. We're going to talk about linear equations in one variable. And what that means is, for example, ax plus b equals 0. Or of course your variable, I know they're all letters, but your variable is the x variable. A and b a lot of times represent constants. So for an example, 3x minus 12 is equal to 0. This is an equation, and what we're trying to do is find the statement that makes this equation true, this left side equal to the right side. This is called a solution, and you probably can figure out what number that is. What number does x need to be so that we get a 12 here, right? 12 minus 12. And then x equals 4 is the solution. 3 times 4 minus 12 is 0. Okay, that's the solution of 4, and it makes both sides equal to 0, so it balances out the equation. The set of all solutions is called the solution set, and in this case there's only one, it's just 4. And a lot of times we write the solution set in these little curly brackets. So there's only 4 here, but if there were more, they would be separated by numbers and in order, right? Like this. But in this one, there's only 4. 2 or more equations that have the same solution set are called equivalent solutions, or equivalent equations, excuse me. Here's an example, 3x minus 12, and how we would solve it. We know the answer is 4, the solution, but we need to use two properties, addition and multiplication or division. So whatever we do to one side of an equation that's equal, we have to do the other. So for example, this statement is true, right? If I add 1 to the left-hand side, the statement is no longer true unless I add 1 to the right-hand side. Then it is also true. It continues to be true. The statement does, right? Well, that's what happens here. For us to solve this, we need to go ahead and add 12 to both sides of the equation, and the equation is the middle here. I get 3x equals 12. And then we do multiplication, which is the same as division. We can either multiply by 1/3 or divide by 3. And you see that we get x equals 4. So that's called our solution, and the steps we used are we can add anything we want as long as we do it to both sides, and we can multiply or divide by anything we want as long as we do it to both sides. And we want to do it in that order. We don't want to divide first or multiply first. We kind of want to isolate the variable x. Here's another example. I'll write it out. 2x minus 3 equals 2. Here we have a little product first, right? There's a couple options we can do, but it might be helpful to multiply it out. Or we could divide both sides, right? Let's see about multiplying it out. Multiply that 2 through. I need to isolate the variable term, which is that, so I'm going to add a 6 to both sides. This is exactly how I would do it if I was solving the problem in Notebook. And then I need to divide, because this says 2 times x, so I need to divide by 2. And that gives me x equals 4 as the solution, and we can check that. If we put that 4 into here, 4, it should equal 2, right? 2, 4 minus 3 is 1, equals 2. 2 equals 2. That's the check. That's how you're solving an equation, looking for the solution. So here's some steps for solving a linear equation. Simplify the algebraic expression on each side by removing parentheses and combining like terms. That's kind of what we did here. We removed parentheses and combined like terms. Collect all variable terms on one side and all numbers on the other. Okay, we collected the variables on the left and we got the numbers to the right by adding and subtracting. Isolate the variable and solve. Check the solution in the original equation. Okay, so let's try this one here. See the answer. We got 3 times 3x minus 4 equals 15. first time I multiply them through. So let's do that again. Multiply them through. 9x minus 12 equals 15. I'm isolating the 9x, so I'm going to add 12 to both sides. Finally, I'm getting the variable by itself by undoing the 9 times. I'm dividing it by 9, dividing it by 9. 9 divided by 9 is 1. 27 divided by 9 is 3. Now check our solution, right? 3 times 3 times 3 minus 4 equals 15. Start on the inside first. It's always how you start. 3 times 9 minus 4 equals 15. 3 times 5 equals 15. Checks out. Let's try this other one. Okay, we're going to work on this problem here with the 3 times 2x minus 5 equals 10 minus the quantity x plus 5. There's a lot going on here, but just do it slowly. Distribute the items you need to distribute. The 3, and then you might put a 1 here for negative 1, right? It's a negative sign. So here we have 6x minus 15, 3 times negative 5, equals 10 minus 1x, or x, and then minus 5. Now let's combine terms. 6x minus 15 doesn't combine, but the 10 and the negative 5 make 5. Now you're to the point where you have x on both sides. Well, you need to get them to one side. So it's just like if I want to subtract 5 on both sides, I want to add x to both sides. 1x, right? This gives me a 7x minus 15 equals 5. Now you can kind of see we're back to the beginning here. I need the x alone, so add the 15. Seven x equals 20, and with last step, isolate that x is divide by 7. When 7 divided by 7 gets 1, we don't want to do the fraction over there, so we leave it as x equals 27ths. Okay, so in this problem we're going to look back here and show how we might get the 27ths in there and to check it, because it's not the easiest thing in the world, right? Well, what I'm going to do is work out what the left hand is and work out what the right hand is. So we have 3 times the quantity 2x minus 5. So what I'm going to start with is try to get the 2 times the 27th. That's the 2 times x. Then I'll subtract 5, then multiply by 3. I'll work from the inside out. 2 times the quantity 20 divided by 7. Like that. Enter. And I leave it in there, 47ths. Now, minus 5. Enter. 5/7. Then times 3. That's the left-hand side, 15/7. Now if I can get 15/7 on the right, we're set. On the right, it's 10 minus the quantity x plus 5. So we want 27ths. We want to do it in, 20 divided by 7 in parentheses so that it looks like a fraction when you're putting it in there. 27ths, right? And then I'm going to add 5 to it. Hit enter, and then that's going to be a negative sign, so multiply it by negative 1. It's the negative of that, and then add that to 10. 15/7. So we notice that 15/7 and 15/7 is true, therefore 27 is the answer. So it's definitely challenging, but if you work from the inside out, you can always check your answer. Solve this with a linear equation with fractions. So this gets a little bit more challenging. Here we have fractions, and we want to solve the equation. There's one variable. Here it's t. What do? Well, we need to find the least common denominator. We need to find 4, 3, and 12, if we were to add them up. and the least common denominator is 12. What we want to do is multiply by 12 on each of these values. So let's write out the problem here. T minus 2 over 4 minus 1/3 equals 5 minus 1/12 times 3 minus t. Now you're going to see why I multiply by the LCD. So LCD is 12. I'm going to multiply by that on both sides of the equation. And that's something I can do because when we were solving those things before, I divided by, like, say, 3 on both sides, right? But I'm going to start out by multiplying. And so I'm going to start out by putting any kind of adding or subtracting in a fraction in parentheses. And I only have that one to do it. So I'm going to multiply by 12 on the left side of this equation, which means this term gets multiplied by 12, and so does this term. This term on the right gets multiplied by 12, and so does this term. Now the reason why I do that is because the fractions are going to reduce. The 12 divided by 4 makes a 3, and there's no fraction. It becomes 3 times t minus 2. This one, 12 divided by 3 is 4, minus 4, equals 12 times 5, 60. 12 divided by 12. The reason why we did that is so that these would cancel out. 1 times 3 minus t. Now we're going to go ahead and distribute and combine like terms, get everything isolated on the same side, right? So 3 times t, 3t, minus 6, minus 4, minus 3, plus t. Add things up. 3t, a negative 6 and a negative 4 make negative 10. 57 plus t. Let's now do some algebra where we get the t to the left. Subtract 1 t off because I'm trying to get t's together, get the numbers on one side and t's on the other side. 2t minus 10 equals 57. Add 10 to both sides. 2t equals 67. Divide both sides by 2. T equals 67 halves. Either I have a mistake someplace, or because I have negative 67 halves, but I think it's positive. It's a little harder to check those ones, but you could stick it into a calculator to check. My suggestion on this one is LCD. And you want to multiply each term by the LCD and put these parentheses in so that you get distribute the negative through both of them, right? So the LCD is a 3 and a 7. You need to take the 3 and the 7, 21. So you're going to go in here and multiply by 21, 21, and 21. Now you should reduce and simplify right away. And I kind of have it worked out here. You see, I've already multiplied by, this is the reducing portion right here. You reduce it down there, you distribute the 7 and the negative 3, then you combine like terms, and you should get your answer. Okay, in the last part of this section, we're going to do solving for a variable. First you want to solve for y, and then you want to solve for x in here, just to see the different ways, right? So pick your variable, point it out here. I'm going to solve for that guy. So 5y minus 3x equals 6. You just do the same thing. If you're solving for y, I'm isolating this term. I get rid of the rest of the stuff. I don't want the 3x on the left side, the negative 3x, so I add a 3x, right? See? 5y equals 3x. I'm going to put it in front instead, just because I like doing it that way. And then I'm going to divide by 5. So it didn't matter that that wasn't a whole number like just the number 3. You're still going to add 3x. It's the term 3x, 3 times x. And who knows what x is, but if you multiplied them together, you'd have an answer. Now I'm going to divide both sides by 5. Now instead of dividing the whole thing by 5 like that, I'm going to divide each term by 5. That way I can write it kind of like a y equals. Y equals mx plus b, kind of in a line form, right? That's what this seems like. So I do 3x over 5 plus 6/5. That's how I would write that answer. I do have the equivalent answer there, dividing both sides by 5. But more useful, as in like a line, you would divide each term by 5, which is the same thing as dividing both sides by 5 because they have common terms, right? Like denominators, you could just put it over 5. Okay, let's look at the next one. Solve for x. A little bit more complicated because it's an x, right? 5y minus 3x equals 6. Instead of adding a 3x to both sides, I'm going to subtract a 5y. Doesn't really matter, but I'm going to put the negative 5y on the left. Like this. Why? Because it just says minus 5. It's easier to say 6 minus 5 than it is negative 5 plus 6. It could go either way. Second, again, I'm going to divide both sides by negative 3. I'm going to do each term. It's the same thing. You'll see the answer right there. But if I do each term, get x equals 6 divided by negative 3, negative 2. Negative divided by negative, plus 5/3 y. Now is that the same thing as this? It is. You can see the 5/3 y, right? 5/3 y, and negative 6 divided by 3 is negative 2. How do I get back to that? Well, at this step, I could have just did this. X 6 minus 5y divided by negative 3. Now, that's not what I have, is it? Well, how do you deal with that negative down there? You can multiply the top and bottom of any fraction by whatever you want. If I have 2 over 2, that's the same thing as multiplying by 3 over 3, which is 6 over 6, right? We still have 1, right? So I can multiply by whatever I want as long as it's top and bottom. So I'll multiply the top by negative 1, the bottom by negative 1. Here I have negative 6 plus 5y over positive 3. And then I can just rearrange the order if I'd like, again with that negative on the right. So they're the same, they're equivalent. So notice when there's a negative number in the denominator, you multiply the numerator and denominator by negative 1, and the denominator becomes positive. So then you rearrange the values so it looks nicer. Nicer means it just less ink. The negative number, if you put it first, then I have to put a plus sign in there, right? All right, let's look at this example here. We have an area problem. Formula for finding the area of a trapezoid. Let's solve this for little b right here. Well, it's complicated, right? Not really. You just want to undo it. It's kind of like wrapping or unwrapping a present. That's where I want to get. I got to get it free. It's on the inside right now. I got to get it free. So I have the 1/2 here. I can either distribute it in, or why don't I try multiplying both sides by 2, like this? Go in here and say, I'm going to multiply the left by 2 and the right by 2. This is all being multiplied together, so it's one side. There's no addition. This is a number in parentheses, so it's considered a multiply, right? Well, then I've got 2a equals, the 2 divided by 2 is 1. Now I'm left with parenthesis big B plus little b times h. There we are, step 2. Now I want to get rid of, I'm solving for little b, so I'm trying to unwrap it. I can multiply the h through, but why don't I just divide by h? That's another option, right? Divide by h, divide by h. This is all being multiplied. It's like one number times another number. So divide, I can just divide them out. 2a over h equals, now the parentheses aren't needed anymore, right? I don't need those parentheses because they're not doing anything. All I'm solving for little b, so last step to do is subtract the big B. 2a minus big B, I got the 2a over little h, equals little b. Now keep in mind, the big B is not over a little h. If you wanted to write it over little h, then you got to do the common denominator thing. It needs an h and an h. So 2a minus bh over little h. That's the same thing. This is equivalent to this. So with this problem, when you have something on the inside like that, start taking the outside things away. Get the outside things off of there. This isn't the only way to do this problem, but I'm not going to go over a million different ways. Another way would be to multiply the half in, multiply the h in, work that way, but this one seemed to go pretty fast this way. Looks like our last problem is solving for temperature. So we have the Fahrenheit scale here. Take 9/5 of the Celsius and add 32, and you'll get your Fahrenheit. Okay. Well, let's solve that for the Celsius. Fahrenheit equals 9/5 of C plus 32. I'm going to try to get C by itself. Before doing anything with this 9/5, why don't we just multiply 32? Or sorry, subtract 32. I'll write F minus 32, 9/5 C. Now I'm almost done. One step, right? I just got to get rid of that 9/5. And how will I do that? Well, can I divide by 9? That'll get rid of the 9. And then if I multiply by 5, I can get rid of the 5. So why don't we do it in one step? Multiply by 5/9 on the left. Notice I could do it by each term on the F and the negative 32, but I could also do it by the parentheses. The whole side gets multiplied by 5/9. Cancel, cancel, and I'm left with 5/9 times F minus 32 equals C. 1, that's a 1, right, when they cancel 1C. And that's the Celsius. See if you can try this one here for perimeter. The perimeter equals 2 times the length, that's an L, plus 2 times the W. You want the L, solve for the L. I've got the answer there. That means you're going to subtract the 2W, and then you're going to divide by 2. You can already kind of see it, right? Okay, so I'll leave that one. And then this one down here, try this one. S equals A divided by 1 minus R. Solve for R. Think, how do you clear the fraction? How do you get rid of the fraction? I'm going to do this one here, but I'm going to give you a second to do it. You can pause it. We're going to do this one now. I'm trying to get R, and R's in the denominator. So I need to get it up so I can solve for it, so I can get R equals. Well, if you're ever in that situation, you have something in the denominator, it's a quantity. Multiply both sides by that quantity, and it becomes upstairs, right? Now we have 1 minus R over on the left. I'm going to put the S first, just so it looks normal. And then these cancel. See? Now it's up. What I'm doing is using the rule that I can multiply by anything I want as long as I do it on both sides. Now I'm going to multiply that S inside, or I can divide. It doesn't matter because I'm trying to get at the R. What do I want to do? Let's go this way. Let's divide by the S. That leaves me with 1 minus R over A equals A over S. These are not needed. Let's subtract 1 on both sides. Negative R equals A over S. Writing my S is weird. A over S minus 1. Now it says negative R. That's not what I want. Two options. Flip everything, meaning put the R on this side, which is actually adding an R, and then subtract everything and put it on that side. Or just multiply by negative on both sides, right? Multiply by negative 1. Multiply by negative 1 on both sides. That gives me R, negative A over S plus 1. Probably would be written as R1 minus A over S, and then they'd probably put it together. What I mean is like terms. S, right? Like terms would be S over S multiplied by S over S. S minus A over S. And that's what R would be equal to. But either one is fine. It just probably would be this one. Be written more like that. Alright, so there's section 1.1. Hope you were able to get through the problems up here that I asked about. And those answers came out. If not, maybe that's something you talk about in discussion or reach out for some more help.